warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we will be finding out how to do CFA, that is Confirmatory Factor Analysis, in AMOS. Now, what is Confirmatory Factor Analysis? It is basically a statistical technique which confirms that the indicators or your observed variables are contributing to the latent variables variance. That means they are an essential part of the latent variable. As they are reflective indicators, we need to confirm that they reflect the true nature of the latent variable. That is the reason we do confirmatory factor analysis. Now, once you have built in a model on the basis of theory, you need to test that whether the indicators which you have included for measuring your latent variable do conform to that latent variable or not. So that is the reason we do CFA. There is one more factor analysis which is exploratory factor analysis done through SPSS. So in that, if we are uncertain about the indicator's nature, if we are uncertain from the theoretical point of view that whether these indicators contribute to the relative meaning of the latent variable or not, so then we conduct exploratory factor analysis, which is known as EFA in SPSS. I would be making up a video on how to do EFA also in the upcoming sessions. For now, let us concentrate upon confirmatory factor analysis in AMOS. So, confirmatory factor analysis is a statistical method used to test hypotheses about relationships between observed variables and their underlying latent constructs, or also known as factors. It's a deductive approach, meaning researchers have a predefined model based on theory or prior research and test how well the data fits the model. CFA helps validate the structure of measurement instruments and assess the reliability and validity of the measures. So CFA happens to be a part of measurement model assessment in AMOS. I have explained it very well in my video on confirmatory factor analysis and measurement model assessment. You might go back and look into that video in the playlist. Also, I have explained how to draw the first model in AMOS through my video on multivariate normality assessment in AMOS. You might go back and look into the video to see how to draw your first model or a measurement model in AMOS. Now, these are the various indices which we refer to when we are doing measurement model assessment. So, all these fit indices which you see over here, RMSEA, GFI, SRMR, CFI, IFI, chi-square by degrees of freedom, PCFI and PNFI. We need to compare the observed values, the values which we have got through our data, with these recommended values. So if they fall within the thresholds which are recommended, then we say that our model, the measurement model, is deemed to be fit for further analysis, and then we can go in for structural model assessment. These are some of the useful resources which you can refer to. Brilliant resources. One is confirmatory factor analysis by Brown and Moore. The other is confirmatory factor analysis by Harrington. So now let us go to AMOS and see how the real thing happens. So here we are in our measurement model, which we drew in the last video. The covariances are already present between all the latent variables. You have to draw these covariances and then we have to run the model. So I press on calculate estimates. You see it's mentioned calculate estimates, and then the model is run. I got chi-square value of 358.8. Let me go to the view text option to check in the results. So when I go to view text option, I get the results like this. The first step is to check the model fit indices. I'll click on model fit and now I'll check all those parameter indices which I referred to. Now, how to check them? So let us keep this at one side so that you can easily relate to the indices which we have shown you in the presentation. So these are the indices over here. Now we just need to compare them. So you see here, the first is Cmin by df, that is chi-square minimum value divided by degrees of freedom. It has to be below 5. In our case, it is 2.243, right? So in our case, it is 2.243. So you see here, the recommended threshold is below 5. This parsimonious fit relative chi-square by df should be less than 5. So this is okay. Next is we need to see RMSEA. RMSEA, root mean square of error approximation, should be less than 0.08 for a good model. So let us see, this is RMSEA, it is 0.078. So well within the limits, below 0.08. Next is GFI, it should be greater than 0.90. So let us see GFI. So this is GFI. It is little bit lesser than 0.90, 0.852, but we can assume it to be quite right to move ahead with the structural model assessment if other indices fulfill the threshold recommended values. Now, next is SRMR. You see here, standardized root mean square residual. It has to be less than 0.08. We don't see SRMR over here in the standard results. I'll tell you in a while how to view the SRMR results. For now, let us see CFI. CFI should be greater than 0.90. In our case, it's 0.915, quite good. Then we should see PCFI 0.770. Threshold is, it should be greater than 0.50. That is the recommended value. PNFI, parsimonious normed fit index, has to be greater than 0.50. So here again we have it greater than 0.50, it's 0.722. Now first let us come back to standardized root mean square residual. SRMR should be less than 0.08. So you don't get the SRMR over here, but how to get it? I'll show you. So you will not get it unless you have the plugin installed. So I have the plugin installed. You can go to the Gaskination StatWiki by Professor James Gaskin and download the plugin and install it in your AMOS. Now here you see standardized RMR, SRMR. I need to click on standardized SRMR. So now we have the standardized RMR, SRMR, which is 0.0642. The recommended value was less than 0.08. So this is also quite good. We've checked all the model fit indices. Now, what is the next step? Next step number 2 is go to the estimates. So now I'll click on estimates. You see here estimates and go to the scalar options, and then I see standardized regression weight. So this is the standardized regression weight. Now, all of this which you see are basically indicating that your indicators, for an instance FQ1 to FQ4, how well they are contributing to the latent variable, that is FQ, because all of them are reflective of the latent variable. So all these values should be greater than 0.5. In case you see any of the values lesser than 0.5, then you go back to the model and you have to remove that indicator. So you see here, if it is less than 0.05, let me go to standardized estimates and check. So these are the standardized estimates you see here. If it is less than 0.5 in any case, here we don't have any of the values less than 0.5. You see here on the arrowheads, no one is less than 0.5. So in case it is there, These are known as factor loadings in confirmatory factor analysis. So these factor loadings have to be at least 0.5 for each indicator. Okay. Now, what is next? Next, again, we'll go to view text. We've checked the standardized regression weights. They are quite okay. All of them are above 0.5. What is next step? Step number 3 is check modification indices. Now, we have to check the modification indices. Where are the modification indices? They are not displayed over here. How to get the modification indices? Now, you go to view, analysis properties, output, and click on modification indices. You see here modification indices. Click on modification indices and click cross, and again click calculate estimates and go to view text, and now you have the modification indices. Under modification indices, we have to see the covariances. Click on covariances. What are covariances? Basically, it's the direction of relationship between the two variables. Whether it's a positive or a negative covariance, it determines the direction. Whether one increases, other also increases, that means positive covariance. If one increases, other decreases, it is negative covariance. So it determines the direction of relationship between two variables. What is correlation? It determines the direction as well as the strength of covariance. So we say that correlation coefficient R is between -1 to +1. So now you have the strength also measured. Then what is regression? Regression is basically when we are trying to find out the relationship between two variables. So that is how we differentiate between covariance, correlation, and regression. Also remember that when covariance value is standardized, it is known as correlation. Now we have to check the covariances. So these are the covariances you see over here. Now, what to do with these covariances? You see, E19, E20, these are the error terms. So they are covarying up to a level of 48.478. That's the modification in this. And it says that if I covary both of them, what will be the change in my chi-square value? The chi-square value will change by 0.281. So how much the chi-square value will decrease if I add the covariance between the highest error terms? So these are the highest error terms if I covary them, but in this case I don't need to do it because all my standardized regression weights are above 0.5. My model fit indices are okay as per the recommended threshold limits. So in this case, I do not need to do it. In case my model fit indices are not okay, or my standardized regression weights, even after removing those indicators which have the factor loading less than 0.5, the model fit is not okay, then I come to the modification indices covariances and I try to covary those terms, those error terms which are on a higher side, so that it helps to decrease my chi-square value and help to achieve the model fit. I hope I am being quite clear so that you can understand it when you are doing the model fit assessment. Now, the last step is step number 4. Go to estimates and check on the matrices. So I went to the estimate, check on the matrices, and I have to check standardized residual covariances. I click on standardized residual covariances. So even if after removing the indicators which had factor loading less than 0.5, and after that you check the modification indices and covaried the error terms also, then also the model did not deem to be fit. So one more step which you can carry on to rectify your model is go to the standardized residual covariances. Now, as per the recommendation by Brine, the reference is Brine 2001. The author says that most of them should be less than 2. So in this case, if we look at it clearly, we have one which is 3.511. We have one which is 2.1. That is okay. That is close to 2. There should not be majority of the values in this matrix, standardized residual covariance matrix, which are more than 2. In case you see more than 2 values belonging to any of the indicators, you see these are all our indicators. Then you need to remove that indicator. So for an instance, I see BI3 has 3.511. So that is much higher than the recommended threshold of 2. So I need to remove BI3 from my model. That will help me to build a good model for my assessment. And then I can go ahead with my structural model assessment. So I hope the video was quite clear and informative for all of you. You enjoyed watching it and you will definitely recommend it to your friends and faculty colleagues. It will help them to do the measurement model assessment along with the confirmatory factor analysis, which is of course a sub part of measurement model assessment. Thanks a lot. Keep learning and keep watching for more.